All right, hi everybody. So let's go and get into interpreting the concavity for these graphs. So remember from previous material in chapter 2 that we had the statements like first derivative tells us something, second derivative tells us something, right? So, both are positive, increasing at an increasing rate. Both are negative, decreasing at an increasing rate, right? Your decrease is getting bigger. If your derivative is greater, first derivative is positive, second derivative is negative, then you're increasing at a decreasing rate. If your first derivative is negative, second derivative is positive, then you're decreasing at a decreasing rate. So here's a visual representation of what that means. So figure 3a, we are increasing at an increasing rate. So what I would say here, this first bullet point is 3a. Okay, so 3b looks like we're increasing, but that increase is kind of tapering off. It's decreasing. So I would say we are increasing at a decreasing rate. So I would say the 3b is that second one, the third one, sorry. And figure 3c, we're decreasing, but it looks like that decrease is sort of tapering off a bit. So I would say we're decreasing at a decreasing rate, like that decrease is tapering off. So I would say 3c. And this last one, we are just decreasing, just going straight down. So decreasing that increasing rate. That decrease is increasing, right? It's not slowing down. So I would say 3A, 3D, 3B, and 3C, kind of matching them up with here. But what are we doing this for? So let's go ahead and we can actually interpret graphs like this. So we're going to skip this one. This one's a little too involved. So let's go ahead and look at 57. Okay, so the graph below illustrates the relationship between average cost A in dollars of a particular commodity and the number Q of the commodity produced. Okay, so here we have a graph here. We have a couple points here like 1525. This just means that what the graph is. So how do we interpret this, right? This is what we want to interpret. So what to do? Here's kind of like a what to do checklist. Okay, so you want to state whether you are increasing or decreasing at an increasing or decreasing rate. So you want to follow along these guidelines here. Are we increasing at a decreasing rate or etc.? So we want to notice those things and we want to state those things. So that's one thing we want to talk about. You want to talk about the mins and maxes, right? We want to talk about that. So we see kind of this minimum right here. We want to state something like that. And we want to talk, oops, talk in context of the problem. Okay, so it's a long statement, so let me pause the video and write it out, and then we will go over it. Okay, so here is the statement of what's going on in this graph in the interpretation of the question using our increase, second derivative, increase, decrease rate. So let's go ahead and piece this together. So I know that I have this min right here at 1525, right? So let me just go ahead and check out what's going on before that. So this first statement here, as a number of the commodity produced increases towards 1500, like as we're coming this way, right? The average cost is decreasing at a decreasing rate because this figure, I don't have any particular numbers, but this figure looks like this little portion looks like 3C to me up here, right? We are decreasing at a decreasing rate. Okay, so that's where I'm getting that part from. And then at this point here, we actually have a minimum. We have at 1500 commodity, we reach a minimum of $25. So I'm going kind of from left to right about what's going on in the graph. And then lastly, if I look here, it looks like after this min, we were just shooting off increasing, right? So to me, that looks like increase at an increasing rate. So this would be 3A. So if I put all that together, you know, at 1500, the commodity produced, the average cost reaches a minimum of $25. And then after that, then the number of commodity produces increases beyond 1500. The average cost is then increasing at an increasing rate because of what I'm interpreting here. But that's how you would interpret these graphs using, decreasing at an increasing rate. You want to talk about the mins or maxes like we did here, and make sure you're talking about like the context of the problem, like you understand what's going on, right? This is a applied calculus class, so we have to do some interpretation, right? But okay, so that's for that question. Let's go ahead and try out another applied question. So, question here about business advertising revenue. So, the owners of a photo framing store relates the amount of money they spend on advertising to the number of people who see their advertisement with the function revenue function R of x equals 900 x squared minus x cubed all over 30,000. And we are within 0 and $900. Okay, so dollars spent. So R is individuals, X is in dollars. And the question here is find the point of diminishing return for this model. So what does that mean? So here we have here, point of diminishing returns is a point in which the addition of another factor produces less output than the addition of the previous factor. Meaning like at this specific point of diminishing returns, after that, you're just gonna not be making as much money. Okay, so let's go ahead and try this out. So the way to do the find your point of diminishing return, as the theme with this section is finding your second derivative. So to find a point of diminishing return, first thing we got to do really is find your hypercritical value. So find hypercritical value. All right, so I have this function here, right? It's not just a regular function. But what we can do is actually factor out this 30,000 because it's just a number and make it the derivative a little easier on this. So we can rewrite this as R of x equals 1 over 30,000 times 900 x squared minus x cubed. So now when we take a derivative, we can just treat this as a coefficient and bring it along with our derivatives and just worry about this expression here. So let's go ahead and check that out. So I have R of x equals 1 over 30,000 times 900 x squared minus x cubed, right? And I want to get my hypercritical value, meaning I need to find a second derivative and set that equal to 0. So let's go ahead and get that second derivative. So the first derivative of this is just going to be this 1 over 30,000 just comes along. Okay, so that comes along with it, but then the derivative of this part right here is just going to be 1800 minus 3x squared. Oops, sorry, forgetting the x. 1800x minus 3x squared. Okay, so that's my first derivative. Now my second derivative, right? Same thing, the 1 over 30,000 could just come along, and I'm going to end up with 1800 minus 6x. Okay, so what I need to do is set this equal to 0 to get my hypercritical value. I'll say set second derivative equal to 0. So 1 over 30,000 times 1800 minus 6x equals 0. I'm going to solve for x now. So I'm going to multiply both sides by 30,000 so that I can cancel out that. Okay, so then what I'm left with is 1800 minus 6x equals 0 still, right? 0 times anything is 0. And now I'm just going to solve for x. So I'm going to move the 6x to both sides. So I'll end up with 1800 equals 6x. Then I'm going to divide by 6. And what I end up with is 300. So that is my hypercritical value. Okay, so now we have our hypercritical value. Now we just have to verify that it actually is a point of diminishing return. And the way we do this is to see that it's concave up before it and concave down after it. So what we're going to do is a number line to test for concavity. So what I'll say here is number line, excuse me, step 2, number line. So here's a number line, right? Be careful here because we're doing an applied problem. We are only between 0 and 900. So what you want to do is actually plug in your endpoints, 0 and 900, to see if you're actually diminishing these returns. So we have a number line from 0 to 900. And then right here we have about like our critical value, hypercritical value, which is 300. So you just want to test out these points to see whether it's concave up, concave down, right? So we have to plug those for concave up, concave down into our second derivative. So we got to plug it into there. So I'm going to plug 0. So our double prime of 0 is 1 over 30,000 times 1800 minus 6 times 0. And what does this equal? It says like 1800 over 30,000, which is just 0.06, which is positive. So that means it's concave up. So right here will be like concave up. And so now we'll check out 900. So we'll have R of 900 equals 1 over 30,000 times 1800 minus 6 times 900. All right, so if we simplify this out, we get 1800 minus 6 times 900. So this is like negative 3600 over 30,000, which is just negative 0.12, which is negative. So that means we're going down. So we're going down right here. So what does all this mean, right? So what this means is that 300 is our point of diminishing return, that we're concave up before it, concave down after it. So that means that's after 300, we're not, our revenue isn't so well. So let's go ahead and write that in a statement. So solution. We are concave up on 0 to 300. Remember, we're between 0 and 90 because this is a real applied problem. We're not going to like negative infinity. And concave down on 300 to 900, right? Up to 300, down after 300. Therefore, the point of diminishing return is $300 spent on advertising. Okay, so that is how you would find a point of diminishing return question. So you will see that come up. It's a staple of applied calc. Um, so here's this last question here, example 4. It's the last question of the section. So it's putting together everything we've covered about critical values, hypercritical, intervals of increase, decrease, relative max and mins, intervals of concavity and inflection points. So it's a putting together everything from 3.1, 3.2. I want you guys to try it out. And then, so pause the video, give it a shot, and then I'm not going to go over it, but I'm going to have it written out once you pause the video. So go ahead and try it out. Okay, everybody, welcome back. Hopefully you try the problem and give it a shot and see how well you are understanding the concept. So won't go over every single detail, but in the first example, find critical values and hypercritical values, right? Critical is just the first derivative. Take the first derivative, set it equal to 0, and solve for x. Okay, hypercritical is second derivative, so second derivative, set it equal to 0, and solve for x. So those are your hypercritical and critical values. So intervals of increase, decrease, right? That's the first derivative, right? And that's where we got to do a number line. So we're trying to find increase, decrease. You have our critical values 2 and -2. All right, put that in red there. And then you're just trying out points around it and seeing what you get, positive or negative. So if it's positive, then it's increasing, and negative, it's decreasing. Okay, and this is how we get the intervals of increase, decrease. All right, so pause the video if you need to copy this down. Okay, so letter C is just find the relative max for mins. So we know from part B that we know what our mins and maxes are, right? We know that we're going up here, coming down here, that's a max. Going down here, coming up there, that's a min. That's our first derivative test from 3.1. You could also use a second derivative test, but that's just more unnecessary work if you didn't already have a number line like this for your first derivative. So what we really need to do is just then find the coordinate point, meaning we need to find the y values, right? So we just plug our critical values back into our original function, which was f of x equals x cubed minus 12x plus 2. We're just plugging our critical values into there and getting our y value. And then we have our coordinate point, our min and our max there. Once again, you could have just done a second derivative test up here, right? But we already had a number line using our first derivative test, so we didn't really need to do that. Okay, so last one is find the intervals of concavity and inflection points. So intervals of concavity, that is second derivative. So same thing, you got to do a number line. Luckily, we only have one hypercritical value, which is x equals 0. So then we just pick points around it. So I picked -1 and 1. Those are just easy numbers to work with. You could have picked whatever, -2, 2, -10, whatever. But then you just test those points to see what you get. So I got a negative number for -1. So that means we're concave down, and positive number for 1, so you get a concave up. So concave up from 0 to infinity, concave down from -infinity to 0. Lastly, it's inflection point, and inflection point is just your hypercritical value, um, that coordinate point. So we know a hypercritical value is x equals 0, hypercritical value. So you just got to find the y value. So you plug that into your original function here and get your coordinate point, and then that's your inflection point. So go ahead, and if you want to write this down, pause it, write it down. Same thing here, pause it, write it down. But other than that, I'll see you next time. Thank you. Bye.